Hi, Mr. Richards here. Today's lesson is on compare real numbers. And as we look at our real-world link, Major League Baseball has rules for the baseball diamond. A model of the diamond is shown. On the model, the distance from the pitching mound to home plate is 1.3 or 1 3/10 inches. Is 1 3/10 a rational number? Explain. Well, yes, it is rational. Now, remember, rational numbers can be written as a ratio, a over b, or a fraction, a over b. So for explanation, we can say it can be written as either 1 3/10, which is the same thing as 13/10. On the model, the distance from first base, which is here, to second base is 2 inches. Is 2 a rational number? Well, similarly, yes. It can be written as 2 over 1. The distance from home plate to second base is the square root of 8 inches. Using a calculator, find the square root of 8. Does it appear to terminate or repeat? Well, this looks like it's 2.8284. 27125. So, does it repeat? No. Does it terminate? Well, maybe. Now, to determine if the number terminates, on your calculator, multiply your answer to the square root of 8 by itself. Do not use the x squared button. Is the answer 8? Nope. Based on your results, can you classify the square root of 8 as a rational number and explain? And say no. It is not a repeating decimal. So we're keeping it real here today with our concept of real numbers. A rational number, as we talked about in our last lesson, is a number that can be expressed as the ratio a over b, where a and b are integers and b is not equal to 0. Examples, -2, 5, 3 and 76/100 repeating, -12 and 7/8. Well, if we have a rational number, then we're going to have an irrational number as well. An irrational number is a number that cannot be expressed as the ratio a over b, where a and b are integers and b is not equal to 0. And one example is the square root of 2. Because it's about 1.414213562 and keeps going on forever and ever, does not repeat, does not terminate, it just goes on. Numbers that are not rational are called irrational numbers. The square root of any number that is not a perfect square number is irrational. The set of rational numbers and the set of irrational numbers together make up the set of real numbers. Study the Venn diagram below. Too close? Too close to study? Oh, okay, let's back it up. So for our real numbers, we have irrational numbers, such as pi. Remember, pi, if you've seen a giant poster of it, 3.1415 goes on and on and on and on and on forever. Doesn't repeat, doesn't terminate. Here we have the square root of 3. Well, if you type that in a calculator, it just doesn't repeat, it won't terminate either. Rational numbers, then, any number that can be written as a ratio of a over b, so 1 over 2. 0.45 is 45 over 100. 18%, 18 over 100. That's already written as a ratio. And 0.4 repeating, if you were to go through the equation and solve, remember, was 4/9. So those are all rational numbers. Next, we have integers within that, such as -8 and -3. Then we have our whole numbers such as 0 and natural numbers 4, 10, 9. Natural numbers are kind of like our counting numbers, 1, 2, 3, 4, 5. And then whole numbers working our way back out brings in 0. Integers brings in the negative numbers, and rational numbers brings in all those others that can be written as a over b that aren't integers, whole, or natural. So our rational numbers includes a lot of different numbers, whereas our irrational numbers, for now, they cannot be written as a over b and show up as decimals that don't have that repeating pattern and do not terminate. So as we look into now our guided examples, name all sets of numbers to which each real number belongs. For number 1, we have 0.2525 ... Well, the ... means that 25252525 is going to go on forever, so the decimal ends in a repeating pattern. It is a rational number because it's equivalent to 25 over 99. And that's it. It's just a rational number. The square root of 36. Now, don't be tricked here. The square root of 36 is 6. So it's a natural number, it's a whole number, it's an integer, and it's a rational number. What about the negative square root of 7? Well, that's approximately equal to negative 2.645751311 ... The decimal does not terminate, nor does it repeat, so it's irrational. Let's now look at our got it questions. For the square root of 10, typing this into a calculator, we crank out the decimal 3.162277766, and it just kind of keeps going on. This does not repeat. It does not terminate. And like our example said, any square root that is not a perfect square is going to be irrational. What about negative 2 2/5? Well, I can write that as the ratio of negative 12 over 5, the improper fraction there, if you will. And so this is a rational number. And that's it. It's not an integer, it's not a whole number, it's not a natural number, it's just rational. Now the square root of 10 is, well, let me try that again. The square root of 100, if I get ahead of myself here, is equal to 10. There we go. And now 10 is a natural number. It is a whole number. It is an integer. And lastly, it is a rational number. So a number like 10 is natural, whole, integer, and rational. Now we can compare and order real numbers. As it says, you can compare and order real numbers by writing them in the same notation. Now it says to write the numbers in decimal notation before comparing or ordering them. And that will be easiest today, to write all of these real numbers, whether they're rational, irrational, whole, integer, natural, whatever, as decimals. And so in our guided example, we have the square root of 7 compared to 2 2/3. Well, the square root of 7 is about equal to, using our calculator now, 2.645751311. Versus the 2 2/3, which is 2.666666666 on and on forever. Now, if we organize this and write this 2.645, and then we have our 2.666. These are the same. These are the same. Now, this 6 is bigger than that 4 here. So the 2.645 is smaller than the 2.666. So our square root of 7 is less than 2 2/3. What about 15.7% and the square root of 0.02? So 15 7/10%, the square root of 2/100. As decimals, 15.7%, 0.157, just by moving that decimal to the left twice. Square root of 2 is 0.141. We're even in our ones, even in our tenths. 5 is bigger than the 4 in the hundredths. And so 15 7/10% is going to be greater than the square root of 2/100. The other type of question we're going to be asked to do, order the set, the square root of 30, 6, 5 and 4/5, and 5.3 with the 6 repeating from least to greatest. Verify your answer by graphing on the number line. Same process, except there's just more numbers here. Write each number as a decimal, then order the decimals. And so the square root of 30, 5.48, 6, 6.00. We'll get back to why we put the zeros there, zeros there in a moment. 5 and 4/5, 5.80. 5.36, we'll just call it 5.37. We'll kind of round it now. And so look in your ones place. You have 3 5s and a 6. We want least to greatest, so let's narrow in on our 5s. As we go to our tenths place, we have a 3, 4, 8. Well, 5.36 is first, then the square root of 30, then 5 and 4/5, and that's what you see here. 5.36 repeating, the square root of 30, and 5 and 4/5. And that leaves us then with the 6. Now we put the zeros here because it's easier to compare these when you have the same numbers to the right of the decimal. And so just leaving it as a 6, you might accidentally line it up wrong. And so if we just line up our decimal points and have the same numbers, the same amount of numbers to the right of the decimal, you'll be more successful. Now for our got it questions, we'll use the right work zone area, and I'll just rewrite the questions as we go through. So for D, we have the square root of 11 compared to 3 and 1/3. Well, the square root of 11 is going to be about equal to 3.31, and I'll go ahead and write that 6 as well. 3 and 1/3 is about equal to 3.333. And now, a couple ways of mentally going through this. In our ones place, we're the same, so we need to go to our decimals. Tens place is the same, 3 and 3. And in our hundreds place, this 1 is smaller than the 3, and so the square root of 11 is going to be less than 3 and 1/3. The other way, since we're lined up in the thousandth spot, and our ones are the same, I have 316 thousandths and 333 thousandths. Well, 316 is less than 333, so the square root of 11 is less than 3 and 1/3. Two different ways of looking at the same problem. What about E? The square root of 17 compared to 4 and 3/100. The square root of 17 is about equal to 4.12, and 4.03 is, well, 4.03. And so, as we look, same in the ones place, in the tenths place, the 1 is bigger than the 0, and so the square root of 17 is greater than 4 and 3/100. The other way, of course, since we're correct in the ones place, 12/100 is bigger than 3/100. And so the square root of 17 is larger than 4 and 3/100. Let's move on to F. For F, we have the square root of 6 and 25/100 compared to 250%. Woohoo! This is an awesome problem. The square root of 6 and 25/100 turns out to be 2 and 5/10. And you might be going, why is this so awesome? Mr. Richards, you're crazy. Well, that part might be true, but we won't talk about that now. As we get 250% into a decimal, this is 2.50. And before we compare these, let's make sure we have things lined up. We have something in the 1 spot, we have something in the 10th spot, we have something in the 100th spot here, so we need something here, so we can put our placeholder of 0. Well, we're same in the 1s, same in the 10ths, same in the 100s, so we must be the same. The square root of 6 and 25/100 is equal to 250%. I think that's so awesome. Now, let's move on to G. In G, we're being asked to order the set -7, the negative of the square root of 60, -7 1/10, or I'm sorry, -7 7/10, and -66/9. From least to greatest. So we want least to greatest. And then we'll verify on the number line on the page. Don't let the size of the problem freak you out. Just take everything one step at a time. And so we'll have to figure out -7. We'll figure out together the negative of the square root of 60. We'll figure out -7 7/10. And we'll figure out -66/9. We'll do this together. Now, -7, that's just -7.000. Now, the negative of the square root of 60 is -7.745. -7 7/10 is -7.7, and we'll bring in the 2 zeros as placeholders. The -66/9 is -7.333. Now we're all the same in the one spot. We're all -7. So as we look at the decimal portion, remember, on the negative number side, the further away from 0 you are, the smaller your number is. For example, -10 is smaller than -1. And so as we look to compare these, we have nothing here. We have zeros. We have 745. We have 700. And we have 333. The further you are from 0, the smaller your number is. And so which one is furthest away from 0? That's going to be the 745. The negative part makes the 745 the furthest away from 0. So our smallest number is the negative square root of 60. And so that's done. Then 700 is the next smallest. So -7 7/10. Then we have our 333. So -66/9. And then lastly, zeros, so just -7. And so that's our answer. The negative square root of 60, -7 7/10, -66/9, and -7. And as we go to graph this now on our number line, our negative square root of 60 was about -7.74. Well, -7.74 is going to be right around here. And so that was the negative square root of 60. -7 7/10 was perfectly right here. And so that was the -7 7/10. -66/9 was our -7.333. And that is right around here. And so that's the -66/9. And lastly, we had our -7, which is pretty easily right there at -7. So it verifies that negative square root of 60, followed by -7 7/10, followed by -66/9, and -7 is our answer. Now, we did the number line last. If you wanted to sketch out, especially with our negative numbers where they're much more difficult to order from least to greatest when we get into these tiny decimals, If you wanted to use your number line first to get these in order, that's a terrific strategy as well. As we finish up our lesson now with our guided example number 7, on a clear day, the number of miles a person can see to the horizon is about 1 and 23/100 times the square root of his or her distance from the ground in feet. Suppose Frida is at the Empire State Building observation deck at 1,250 feet, and Kia is at the Freedom Tower observation deck at 1,362 feet. How much farther can Kia see than Frida? All right, so we're taking our 1 and 23/100 times the square root of their heights. 1 and 23/100 times the square root of 1,250 is about 43 and 49/100. 1 and 23/100 times the square root of 1,362 is equal to 45 and 39/100. Subtract, and you get 1 and 90/100. So 1 and 90/100 miles further is what Kia can see than Frida. And that is it for this lesson, Lesson 10, on compare real numbers. And that is our last lesson of Chapter 1. Good luck.